I still remember the moment the trajectory line appeared on my screen. A thin, bright red arc sweeping across the outer solar system, bending gently toward Jupiter, like it had been drawn by a careful human hand. My first reaction was confusion, my second reaction was disbelief, and my third reaction, the one I'm still wrestling with even now, was something very close to awe. Because in all my years analyzing deep space objects, tracking interstellar visitors, reconstructing gravitational paths, and predicting orbital deviations, I've never seen anything behave quite like 3I Atlas is behaving right now. We've been monitoring 3I Atlas ever since its faint signature first appeared, moving against the background stars nearly 2 years ago. At first, it looked like nothing more than a dying comet, a loose, dusty nucleus drifting between star systems, weakened by cosmic rays, sputtering out tiny streams of gas that barely formed a tail. Honestly, most of us assumed it would disintegrate long before it reached the inner solar system, but then something happened that none of our models predicted. Instead of breaking apart, 3I Atlas stabilized. Its rotation slowed, the debris cloud around it thinned, and the faint jets that should have become chaotic instead became symmetrical, almost unnaturally so. I had my suspicions early on, long before the public reports, long before NASA's press releases, long before the conspiracy theories exploded online. Something about its behavior was off. Not dangerous, just strange. When a comet outgasses, its trajectory changes in unpredictable ways. But 3I Atlas wasn't drifting. It wasn't wobbling. It wasn't fragmenting. It was making extremely smooth course corrections that looked nothing like natural outgassing and everything like controlled thrust. And yet I kept my mouth shut, because I've been in this field long enough to know how dangerous it is to jump to conclusions. The universe is enormous and chaotic, and odds are always stacked toward natural explanations. But then, a few months ago, 3I Atlas shifted again. Only this time, the shift didn't send it spinning outward or inward. It sent it on a clean, direct alignment toward Jupiter. Not nearly toward Jupiter, not roughly toward Jupiter, directly, precisely, cleanly. If I had shown you the dot plots without telling you they were celestial coordinates, you would have assumed they were GPS readings from a guided aircraft. That's how exact the alignment was. And that's when the real question emerged. If this object is interstellar, meaning it originated outside our solar system, why is it heading straight for Jupiter? And why, with this level of accuracy? I've heard every speculation you can imagine. Some scientists think it's a dying comet being gravitationally pulled. Others think it's drifting into Jupiter's well by coincidence. And some people, including a few colleagues I deeply respect, think this is something entirely different, an interstellar artifact programmed to approach gas giants for reasons we don't yet understand. The public phrased it in a much simpler way. Is it planning to release probes? Believe me, I never thought I'd hear that sentence spoken seriously in a NASA conference room, but I did, and not just once, multiple times, because the closer 3I Atlas gets, the stranger things become. I've been analyzing the rotational light curve of the object almost obsessively. If you aren't familiar with the concept, imagine shining a flashlight on a spinning object and watching how the brightness changes. A chaotic natural object gives chaotic light curves, but 3I Atlas doesn't give chaos. It gives pulses, regular ones, stable ones. In fact, the rotational signature has tightened into an almost perfectly repeating pattern like a heartbeat. Natural comets do not have heartbeats. Every time I bring this up, someone tries to brush it away. Maybe the nucleus is unusually symmetrical. Maybe the jets are firing in consistent directions. Maybe we're misinterpreting the data. And look, I understand the need for caution. I understand the need for restraint. But I'm also looking at the math, and the math doesn't lie. Something is compensating for rotational drift. Something is stabilizing the spin. Something is controlling this object's attitude as it accelerates toward Jupiter. And that's only the beginning. A few weeks ago, the thermal sensors picked up something new, temperature variations on the surface that were not consistent with sublimation. When a comet warms, it releases gas. But the heat spreads naturally, unevenly, and unpredictably. 3I Atlas, however, is showing controlled thermal pockets, small, localized areas that heat up and cool down with shocking precision. The readings look less like natural heating and more like compartment activity. I don't want to use the word internal, because that implies artificial structure. But the internal hypothesis is starting to seem far less ridiculous than the natural one. I keep asking myself the same question over and over. Why Jupiter? If you're traveling between star systems and you need resources, Jupiter is one of the most logical places to stop. It's massive, it's full of hydrogen, the most important element for propulsion, energy systems, and who knows what else. It has dozens of moons, many of them rich with water ice, salts, organics, and geological activity. It has magnetospheres that can power systems and radiation belts that can be used for shielding. If an intelligent civilization designed interstellar probes, choosing a gas giant as a refueling or data gathering point wouldn't be surprising at all. In fact, it would be the safest option, far safer than approaching a rocky world full of unpredictable biological activity, climate systems, and atmosphere. I'm not saying 3I Atlas is artificial. I'm saying this trajectory, this eerily perfect trajectory, raises questions we cannot ignore. And as it accelerates toward Jupiter, the data grows stranger every day. Last week, one of our deep space communication arrays picked up a narrowband emission near the object. It was faint, extremely faint, but narrowband signals almost never occur in nature. They usually require a coherent emitter, something that oscillates at specific frequencies with intentional precision. It wasn't strong enough to classify as communication. It wasn't decoded. It wasn't patterned, but it wasn't random noise either. When the team looked at me for my interpretation, I didn't have one. Not yet. All I knew was that an interstellar object, one not born in our solar system, should not be emitting deliberate narrowband emissions. And yet there it was. Faint, tiny, almost timid, but unmistakably structured. I didn't sleep that night. My mind kept replaying the trajectory map, the line to Jupiter, the rotational heartbeat, the stabilization, the thermal pockets, the narrowband emission. All of these by themselves could be dismissed as outliers or statistical noise. But together they form a picture that is becoming harder and harder to explain away. I'm trying to stay grounded. I really am. But I'm also watching 3I Atlas accelerate at rates that are inconsistent with gravity alone. Tiny accelerations, mind you, barely measurable but real. And they're appearing every time the object makes a micro-adjustment to stay perfectly on track toward Jupiter's equatorial region. Let me repeat that. It's not heading toward Jupiter in general. It's heading toward one of Jupiter's fuel-rich equatorial bands. Why would a comet need that? And that brings me back to the question everyone is whispering about. Is it preparing to deploy something? When a natural object approaches Jupiter, the tidal forces usually tear it apart. But if an object wants to release smaller bodies, probes, devices, sensors, particles, Jupiter's gravity is the perfect catapult. A tiny object deployed in Jupiter's well could be slingshotted into almost any region of the solar system with minimal energy expenditure. If you wanted to scatter probes across space, Jupiter is the gateway. Am I saying that's what 3I Atlas is planning? No, I can't say that. But am I saying the trajectory matches what an intelligent probe deployment would look like? Yes, absolutely, perfectly. The strangest part is what happens after Jupiter. Our long-range models show 3 possible paths. The first one sends it looping around Jupiter and slingshotting outward towards Saturn. The second sends it deeper into the inner solar system. The third is the one that keeps me up at night. A path that sends it directly toward the asteroid belt. Why would that matter? Because the asteroid belt is full of metallic bodies, rich in resources far more valuable than anything Jupiter can offer. Iron, nickel, cobalt, chromium, silicates, water ice, carbonaceous materials, everything an advanced probe would need. If 3I Atlas performs a burn near Jupiter, yes, I said a burn, because that's the only way to explain acceleration against gravitational drift, then any of these 3 paths become possible. And if it chooses the asteroid belt path, then this may be part of a much larger plan. I've run the models 1,000 times. I know the skeptics will roll their eyes when I say this, but the numbers don't lie. Everything about 3I Atlas's behavior resembles something with intent, not random drift, not thermal chaos, not gravitational capture. Intent. Does intent mean intelligence? Not necessarily. Even we build autonomous probes that act with intent: voyagers, landers, drones, robotics. Machines don't need consciousness to follow a mission. But if 3I Atlas is a machine, then it's not a new one. It's old, ancient, worn down by interstellar radiation, stripped of its original structure, coated in dust, weakened, eroded, and barely functioning, a relic from a civilization that might not even exist anymore. Because if the signals are real, if the stabilization is real, if the controlled heating is real, if the trajectory is intentional, then 3I Atlas might not be a comet at all. It might be a probe that has drifted between stars for so long that it now looks like a rock, a probe from a species whose presence we will never know. A probe following instructions written eons ago, a probe whose creators may be extinct, forgotten, or evolved far beyond our comprehension, and now it is coming to Jupiter. As each day passes, I find myself staring longer at the monitors, searching for new anomalies, new emissions, new shifts in trajectory. Something deep inside me is preparing for a moment I can't describe, something between fear and curiosity, because if 3I Atlas really is preparing to release something, then we are not just observing an object, we are witnessing a mission unfold. And if that mission is still active, then 3I Atlas is not just visiting Jupiter, it's executing orders written by someone or something far beyond our understanding. I keep reminding myself that every hour I study 3I Atlas, I am looking at something no human being will ever see again once it leaves our solar system. That sense of finality shapes the way I think, the way I plan every observation, the way I analyze every fluctuation in its brightness or every deviation in its predicted trajectory. When I say I'm cautious, I mean I'm not willing to jump toward extraordinary conclusions when the ordinary ones haven't been fully tested. And yet, as I monitor its approach toward Jupiter, I can't deny that a strange tension has settled over me. I'm trained to interpret data, to distrust instinct, to remain aware of how easily the human brain tries to create patterns. But even with all of that discipline, I can feel myself leaning a little closer to the screen every time a new observation is uploaded. Part of that tension comes from knowing what Jupiter does to objects that wander too close. I've studied tidal forces for years, but the reality still amazes me. Jupiter is a monster. Its gravity can break a comet apart like chalk in a giant's fist, and I keep thinking about the famous case of Comet Shoemaker-Levy 9. I remember reading about it as a teenager, how it was shredded into pieces before slamming into Jupiter in 1994, each fragment exploding into the atmosphere with more energy than a planet-wide arsenal of nuclear weapons. I was too young to grasp the scientific weight of that event. But now, watching the path of 3I Atlas, I understand the parallels more intimately. I'm not saying 3I Atlas is about to break apart, at least not yet, but I've seen enough gravitational modeling to know that Jupiter's pull will test the structural integrity of any object, especially one that wasn't formed inside our solar system. That's why my focus has shifted from the comet's nucleus to the material surrounding it, the coma, the dust tail, the gas jets. If something unusual were happening, if something technologically improbable were hiding inside the natural activity, the coma is where I would expect the first hints to appear. And that brings me to the question I keep getting from people who read the Part 1 reports of my analysis. The question I didn't want to amplify until I had a better grasp on the data. The idea that the comet might be planning to release probes. I know where that speculation came from. I know how easily the words interstellar and unknown composition can spark imaginative theories, but as a scientist, when I hear the question, my instinct is to dissect it. Not dismiss it, but analyze it carefully. First, the physical reality. If 3I Atlas contained something inside it, whether natural or artificial, Jupiter's gravity could theoretically trigger its release, but that would require an internal structure designed to respond to tidal stress. Could such a thing chemically exist? Yes. We know that certain ices hold trapped gases that are only released when the surrounding pressure conditions change dramatically. Could an evolved technological species use similar physics to conceal something inside an interstellar carrier? I can't say no with absolute certainty, but what I can say is that nothing in the data so far resembles the controlled release of anything artificial. What we're seeing instead is normal cometary behavior amplified by Jupiter's gravitational influence. As it gets closer, the rate of outgassing increases. The coma becomes brighter and more asymmetric. Some of the jets become visibly directional as sunlight penetrates different regions of the nucleus. These are physical processes I've modeled countless times, so when I see them now, They don't strike me as extraordinary, but I also have to admit that the level of detail we're obtaining, especially with the ultraviolet readings from MAVEN and the high-resolution work from Mars Reconnaissance Orbiter, is allowing us to observe subtleties we would have missed 10 or 15 years ago. One of those subtleties involves the presence of hydrogen detected by MAVEN. It's not surprising sublimating ice releases hydrogen, but the spatial distribution of it around 3I Atlas has changed as the comet approaches Jupiter's sphere of influence. The hydrogen envelope has elongated, expanding more on the sunward side of the comet than before. Does that mean anything significant? Probably not. The variations likely stem from differences in solar radiation pressure and heating. But I can't ignore the fact that some researchers have wondered whether these hydrogen patterns might reveal something about the comet's internal structure. I'm cautious when I interpret such maps, because the data is complex and sensitive to noise. Still, if the nucleus contains pockets of volatiles arranged in unusual ways, that arrangement could be a clue about how 3I Atlas formed in its home star system. The nucleus itself remains a mystery. High-rise data from Mars Reconnaissance Orbiter gave us some of the closest views we'll likely ever get, but even those images show only a bright core wrapped inside the dense coma, not the bare nucleus. Estimating its size is still difficult. My current working model, and this is only an estimate, places it somewhere between 500 and 900 meters in diameter, but it could be smaller, and the coma could be masking that fact. That's why the passage near Jupiter is so important. If tidal forces stretch the nucleus or crack its surface even slightly, the changes in brightness and dust emission could help us constrain its structure more accurately. But this leads to a question I've had to answer repeatedly. If Jupiter's gravity cracks the nucleus, could small fragments escape and appear as probes? In other words, could natural activity be misinterpreted as artificial behavior? The answer, frustratingly, is yes. Nature regularly produces behaviors that mimic technological intention. For example, comet splitting can generate small, fast-moving fragments that, under the right circumstances, seem to depart in straight lines. Gas jets can create accelerations that appear directed, even though they're purely chemical. Dust clumps reflecting sunlight at a particular angle can look like objects breaking free from the nucleus. And if those fragments reflect ultraviolet light differently than the coma, MAVEN could detect them as anomalous points. That's why I'm very careful about how I interpret every irregularity. Whenever a new data point emerges, a brightness spike, an asymmetry in the tail, a shift in trajectory that falls outside the statistical margins, I run through every natural explanation first. And believe me, I've identified plenty of them. The solar system is full of forces that can tug on an object this size: solar radiation pressure, Jupiter's gravity, outgassing forces, interaction with the solar wind. Any one of these can produce an effect that, on first glance, feels unnatural. I think the reason people latch onto the idea of probes is because interstellar objects carry such a weight of mystery. They come from nowhere familiar. They travel alone through an abyss our species has barely begun to comprehend, and when they appear in our sky, we see them for just a moment, a cosmic blink, before they disappear forever. It's tempting to treat them as messages or carriers or emissaries, but sometimes the universe just throws us wanderers with no narrative beyond their existence. Still, I understand the underlying curiosity behind the question. Why is 3I Atlas heading so close to Jupiter? Why does its trajectory seem so narrowly aligned with the gravitational corridor around the gas giant? Is it coincidence? Or is it something that we're not understanding? I've studied its orbit extensively. When you look at the raw data, the simplest explanation is luck combined with physics. When an interstellar object enters our solar system, it doesn't care about where Jupiter is. It follows the path determined by its velocity vector and the Sun's gravity. If that path happens to intersect a region near Jupiter, it's not intention, it's probability. We have no evidence that 3I Atlas changed its trajectory in any way that suggests control. Everything I've analyzed shows a predictable, non-maneuvering body subject only to standard celestial mechanics. But I'm also aware that Jupiter's gravitational environment gives us a chance to learn something extraordinary. When an object passes this close to a planet so massive, tiny details about its mass, internal density, and composition become measurable. Jupiter acts like a scanner, dragging information out of the visitor whether it wants to reveal it or not. That's why my colleagues and I have set up simultaneous monitoring across multiple spacecraft, Earth-based telescopes, and theoretical modeling teams. We want to capture every ripple of gravitational influence as the comet moves through the Jovian region. And yet, even with all this preparation, there are still moments when the data makes me pause, not because it seems artificial, but because it reminds me how little we truly know about the formation of planetary systems beyond our own. When I look at 3I Atlas, I'm looking at ice and rock and dust forged under conditions we've never witnessed. Its parent star might be older than the Sun, younger than the Sun, or so different chemically that its protoplanetary disk created materials we rarely see here. The slight chemical deviations we've detected so far, ratios of dust to gas, the distribution of hydrogen, the early spectral hints of carbon-bearing compounds, all point to a world that was born under different cosmic rules. If anything inside 3I Atlas behaves strangely as it nears Jupiter, my first interpretation will always be rooted in chemistry, gravity, and physics. But I can't deny that the object's interstellar nature adds an emotional charge to the scientific work. When I watch it on my screen, a faint point of light moving among stars that have been fixed in my mind since childhood, I feel a deep sense of witnessing something ancient. Not ancient like ruins or fossils, but ancient in a way that predates human history entirely. This object has traveled for millions, maybe hundreds of millions of years. It has been cold for longer than our species has existed, and now it's warming under our sun, shedding particles that haven't seen starlight since before Earth had complex life. That's why I find it so important to approach the speculation carefully. When someone asks me if the comet is planning something, I have to remind them and myself that we're the only planners in this situation. We're the ones assigning intention. 3I Atlas is following a trajectory set long before humans existed. That doesn't diminish the wonder. If anything, it enhances it. We're receiving a rare chance to examine material from outside our cosmic neighborhood. And Jupiter's gravity is giving us a lens through which to study it. But I know you want clearer answers. You want to know if anything we've seen so far could reasonably be interpreted as the release of probes. So let me explain exactly what I've observed. About 30 hours ago, our team recorded a brief increase in brightness near the leading edge of the coma. It lasted approximately 9 minutes too long to be noise, too short to be anything like a sustained outburst. My first instinct was to attribute it to a small jet turning toward the Sun as the comet rotated. This is common in active comets. The geometry of sunlight can shift quickly as a nucleus spins, creating momentary bright flares. We compared the light curve to known rotation models, and the timing fit. No artificial explanation required. Then, roughly 12 hours later, the dust tail showed a narrow filament diverging slightly from the main path. Filaments like that are produced when dust particles of different sizes respond differently to solar radiation pressure. When we ran the grain-size simulations, the pattern matched what you'd expect from mixed material outgassing. Again, completely natural. But here's the detail I want to emphasize. In both of these cases, I understand how someone outside the field might misinterpret what they were seeing. A sudden flare could look like a technological release. A thin filament could resemble a departing object. That's why I'm patient with the questions. To most people, these images are abstractions, bright blobs, shifting streaks, blurry shapes. To me, they are signatures of physics so deeply familiar that I instinctively recognize their natural origins. There is one thing, though, that continues to intrigue me personally, and I suppose I should share it because it's relevant to the question of how we interpret unusual behavior. Over the past week, the gas emissions from 3I Atlas have shown subtle variations in timing that don't fit a clean rotational model. In a typical comet, gas jets appear at predictable rotational intervals because the surface structures heat and cool as the object turns. But interstellar comets sometimes have rotational irregularities, especially if their shape is elongated or if they're shedding mass unevenly. The pattern we're observing could mean the nucleus has an irregular spin state, what we call non-principal axis rotation, or tumbling. Tumbling objects release gas in ways that can appear unpredictable. A jet that appears on one side may activate at a strange interval, and another may shut off earlier than expected. From a distance, these irregularities can create the illusion of purposeful timing, even though they're simply the result of chaotic rotation. I've modeled tumbling comets before, and the emission timing we're seeing from 3I Atlas fits that behavior extremely well. So when people say they see patterns, I know exactly what patterns they're referring to. and I also know they disappear when you analyze the data with the right rotational model. As the comet moves closer to Jupiter, this irregular rotation may actually intensify. The gravitational gradient across the nucleus can alter its internal stresses. Even without breaking it apart, Jupiter can torque the object enough to modify its spin. If that happens, we'll see more erratic jet behavior. That means more natural signals that might look unnatural to the untrained eye. So I'm preparing myself for an increase in speculation, because people interpret irregularity as intention. But inside the data, irregularity is just another language the universe speaks. Something else I'm tracking closely is the way the dust tail interacts with Jupiter's magnetic field. As 3I Atlas approaches the planet, charged particles in the dust will feel magnetic forces that slightly change their trajectory. This could produce temporary bends or twists in the tail, similar to the structures we've seen in comets passing near the Sun's magnetic domain. If that happens, we may see shapes that look geometric arcs, waves, or even nodes, but these too are natural consequences of plasma physics. The real opportunity, the one that excites me the most, comes from the chance to detect low-density materials that we normally can't see when comets pass close to the Sunday. Jupiter's weaker thermal environment means some volatiles survive longer before sublimating. If 3I Atlas contains exotic ices that rarely appear in the solar system, this close pass could give us the first ever glimpse of their sublimation patterns. Imagine detecting compounds we've never seen anywhere else, signatures of chemistry that formed under the light of a star we'll never identify. That possibility alone makes every hour of monitoring worth it. And yet, for all of these scientific prospects, I still understand why people frame the event in more imaginative terms. When we think of interstellar objects, we think of journeys. This comet has traveled unimaginable distances. It has crossed regions of space so empty that our language barely describes them. To imagine it carrying something inside a message, a probe, a seed of technology, is to imagine that somewhere out there, someone else has been on a journey too. I'm not immune to that emotional pull, but my commitment to scientific rigor requires me to separate fascination from interpretation. So here's where I stand right now. Everything we've observed as 3I Atlas approaches Jupiter is consistent with natural processes. Natural does not mean ordinary. It simply means governed by physics we understand. The comet's trajectory does not imply intention. Its activity does not indicate controlled release. And yet, I still consider this moment one of the most significant in my career, because we are watching an interstellar visitor interact with the gravity of a gas giant in real time. That doesn't happen often. It may not happen again in my lifetime. As it continues on its path, I'll keep analyzing every change in brightness, every fluctuation in the tail, every shift in the hydrogen envelope, not because I expect anything artificial to emerge, but because I know that inside these patterns lie answers about how worlds form elsewhere in the galaxy. And if those answers come wrapped in beauty, mystery, and the faint echo of questions humans have asked for centuries, then all the better. For me, that's what science has always been, not the search for the extraordinary, but the ability to see the extraordinary inside the natural. And as long as 3I Atlas remains in our sky, I'll keep watching, because once it's gone, all we'll have left are the data, the memories, and the knowledge that for a brief moment we witnessed a traveler from places we may never reach. And that, to me, is more than enough.